Hi everybody, welcome to this video on practice problems talking about molar mass. So in the previous video, in the introductory video, we talked about the equation of molar mass, where it is the mass per every mole, and that really depends on the specific substance that you're identifying. We can get a lot of molar masses from the periodic table, especially for certain elements. Here's an example of what a block would look like on the periodic table, and within this periodic table, or within this block, we have our atomic number, which is how many protons our atom has. We have our symbol, which is how we would represent them with abbreviations instead of the full name hydrogen. And then what we're really interested in today is the molecular weight of hydrogen given by 1.008. 1.008 grams for every mole of hydrogen that we have within our compound or within our substance that we're measuring. What is the mass of 1.2 moles of krypton? And what is the mass of 1.2 moles of neon? So this problem is basically asking you the mass of these two specific substances. And even though they have the same amount of particles, or 1.2 moles of each of these, the masses will be different because of the different molecular weights. Krypton has a molar mass of 83.798 grams per mole, and neon has a molecular weight of 20.108 grams per mole. So about krypton is about 4 times heavier than neon for every single mole of the specific compound. Or even one atom of krypton will be 4 times heavier, around a little bit more than 4 times heavier than neon. So let's convert all of these substances from moles to mass. And if you don't remember the equation, you can end up using unit conversions in order to convert. So in our conversion table, we're going to have 1 mole or 1.2 moles of krypton. And now we're going to use the molecular weight of krypton in order to cancel these out. And we want moles to cancel out on the bottom. So we're going to have moles of krypton on the bottom and 83.798 grams of krypton. It's important to write all of your units, not just moles and grams, but moles of krypton and grams of krypton so you know which ones you can cancel out. After doing the calculation and multiplying these two things together, we end up getting around 100.6 grams of krypton. For the neon, it's the same exact setup. We're going to have 1.2 moles of neon in our numerator, and now we're going to use the molecular weight of neon in order to convert it, where we have 20.180 grams for every mole of neon. If we take 1.2 times 20.180, we end up getting a mass of 24.22 grams. So as we can see here, krypton is about 4 times heavier than neon, and you can also just tell this within the molecular weights themselves. But if you have a gram of krypton and a gram of neon, if you have a mole of krypton and a mole of neon, you'll see that they'll have different masses associated with them. Let's move on to the next problem. A compound of H2S has a mass of 25.1 grams. How many moles of this molecule are there? This one is a little bit more complicated because we're not just given a specific atom, but we're given a compound. Where within this compound, we actually have a mixture of a couple of atoms, where we have 2 hydrogens and 1 sulfur. So this is where we now have to calculate the molecular weight of our compound using the atomic weights of our atoms. And if I say molecular weight for atoms, I really mean atomic weights, but they're really one and the same for these specific processes. So for sulfur, our molecular weight is 32.06, and our hydrogen would be 1.008. But now since we have 2 hydrogens, what we're going to really want to do is multiply it by 2, and you should get 2.016 grams per mole. And then we want to bring over our 32.06 grams per mole. And since these atoms are just bonded together with them, all the molecular weights or all the atomic weights will add up together to give you your molecular weight. So we're just going to add these 2 final molecular weights together in order to get our molecular weight. So this is the molecular weight for H2S. Now we can just do the good old conversion table in order to convert it to moles. I'm going to put moles of H2S using the molecular weight of 34.076 on the bottom. And so the moles will end up on top, and that's what our final answer wants to be in. That's why I have inverted it in the first entry. And I'm going to put 25.1 grams of H2S in the next line. And when you end up doing this calculation, you end up getting 0.737 moles of H2S. So that's how much H2S molecules that we have, is 0.737 moles. 2 moles of a compound has a mass of 76.0 grams. Between H2, F2, and Br2, what compound is this most likely? So this is actually an identification question, the same way that we used density before in a previous video to calculate or to identify a specific substance. We could also find the molecular weight and do the same exact thing. In order to find molecular weight, we want it to be in grams per mole. So we want to find our answer here. And we have 76 grams for every 2 moles of our compound. So we take 76 and divide it by 2, and we'll end up with 38 grams per mole. So out of H2, F2, and Br2, we'll have something that resembles very close to 38. H2 we saw for before, because there was 2 hydrogens in that H2S, and it was around 2.016 grams per mole. We have F2, where F is around 18.998, or just 19.0, and we can multiply it by 2 because there's going to be 2 Fs, and we should end up with 38.00 grams per mole, and that's most likely a correct answer. But let's check Br2. Br2 will be 79.9 times 2, and that's around 159.8 grams per mole. So that's too heavy. So the one that most resembles 38 is obviously F2. So F2 is going to be the compound described here in this problem because it resembles or has the same molecular weight as this unknown compound. The last problem is a different way they could ask the question of talking about mass percentages or seeing what percentage of mass of hydrogen is within H2O. So what we need to do is we need to find the molecular weight of H2O first. We know H2, or 2 H's, has a molecular weight of 2.016 grams per mole. And we know oxygen from the periodic table has a molecular weight of around 16.00 grams per mole. Depending on your specific course, there might be some rules with how many sig figs you use or how many decimal places you use. I'm going to use the rule, usually I have 2 decimal places, except for hydrogen where I'm going to have all 3, or have all 3 decimal places. And now I'm going to add them up together. And so our H2O will have a molecular weight of 18.016 grams per mole. If we wanted to find the mass percentage of hydrogen, we just need to see how heavy hydrogen is compared to water. So really, the percent mass of hydrogen is going to be equal to the ratio of hydrogen's mass to the water's mass. So we do 2.016 grams per mole of H2 divided by 18.016 grams per mole of H2O. So when these things will cancel out, we'll end up getting 2.016 divided by 18.16. And since it's in percentage, you usually multiply it by 100. And we should end up with an answer of around 11.2% H2 in terms of mass. We should end up with 11.2% hydrogen in terms of mass percentage of our H2O. Thank you all for watching, and please like and subscribe, and check out my channel for more practice problems.